Good evening, it's LeetCode time. Let's do our next one. Product of array except self. Product of all the elements except the current element. Oh, I see. Linear time and without using division. So we cannot just do product of everything and then just divide by each element. Okay, so this is the input. The output, what we want to have is product of those. And then for this one, we have product of 1, 3, 4. For this, we have product of 1, 2, 4. And this is product of 1, 2, 3. So product of all the elements except for that element at that index. Okay. So they're all between -30 and 30. I wonder why that is. Okay, there's a follow-up as well. But let's not try to solve the follow-up just yet. Okay, so we want to do this without using division. And we want linear time. Linear time, which means we just want to do some kind of traversal just once, not. So we cannot do like this. For the first one, we traverse this input, we calculate, because that's linear already, and then the second one, we do another linear, that will be quadratic, so that's not linear in total. Okay, so let's think. Oh wait, look at this. The product of any prefix or suffix. So that is giving us a clue as to how to solve this. Some kind of prefix and suffix. Okay, so what if we do one traversal of prefix product and then one of suffix? What can we get from that? Let's see. Let's say we have 1, 2, 3, 4. What would the prefix be? 1, 2, 6, 24. So we're just multiplying by the new element each time. And the suffix would be, we will go from the last one, so 12, and then 24. No, okay, so it has to be like this. So first one, 4, then 12, then 24, and 24 again. So So that's the suffix. Now how can we use this information? Well, the first one we want is basically this suffix. So we want the product of those three elements. The second one we want is this times that. So that is actually this part times this element, because that's the suffix of those two. Okay, we're getting somewhere. Third element would be that times that, which is that times that. Yes, we are getting there. So last one will be product of all first three, and that is just that element. Okay, so now we do know how to use prefix and suffix to calculate this. So what's the pattern here? Let's just try this. Prefix Okay, 3. So that's useful. Okay, so what we want is the first one we want is basically that. We want that. So we want the second to last element of the suffix. The second element in the result would be x1 times wait, that's incorrect. So the first we want is product of all of those, so that's actually suffix 1. That's actually this. Yes. The second element we want in the result is x1 times 3 to 5. Okay. Prefix 0 times suffix minus 3. Okay, and then the third one we want is prefix 1 times suffix minus 2. Okay. Prefix 2 times suffix minus 1, and the last one would be prefix 3. Okay, so we always start with the suffix 1, we end with I mean, we are actually ending with -2. Okay, and in between we are doing 0, -3, so 0 all the way to 1, so 0, 1, 2. So 0 all the way to -2, and for suffix it will be -3. I mean, it's only -3 because we have 5 of them. So what would be the index? Let's, if, okay, if length is n, okay, so first one is always going to be suffix 1 because that gives the product of all of that. Second one will be always be prefix 0 times all of those. Suffix 2. So it will always be prefix 0 and suffix 2. Okay, this is much better. And then it will be prefix 1 times suffix 3. Then it will be prefix 2 times suffix 4. And this will go all the way until -2. Okay. So what we have in between here is prefix 0, 1, 2 until n-2 and suffix 1, 2, 3, 4. One, 2, 3, 4, 0, 1, 2, 3. So this is actually useless, and this is useless. Right. Alright, so we have the solution, we just need to write the code for this now. Let's have a prefixed list and the suffix list. For each number in nums, let's build our prefix and suffix. Okay, let's try to build this in one loop. Okay, so prefix append. We're gonna have to start from, you need a start, then we can continue to multiply. Actually, I need index for the array. No, now we're using a list. I need to look this up, because usually in other languages with arrays and lists, they are separate, but not quite sure about Python. Well, what we do need is prefix 0 to be num0 and suffix. I mean, this is, how can I initiate a list or an array with a certain length in Python? Actually, do not know this. Python create array with size in, oh, I see. You just do okay. That's interesting. Okay, now let's do this. Prefix I, so that starts from 1. So all of the elements right now should be same as the first element in nums in prefix. So prefix I, so prefix 2 would be, no, prefix 1 would be 1. So the current value times nums 1, and then 1 is 2. That would be current value times we do not want current value, we actually want previous value. Previous value times nums I, and the previous value times nums I. Okay, now for the suffix we are doing backwards. So we start with everything with the last element in there already. So n minus I minus 1. So we're starting from the second to last element is suffix n minus I, was that element times nums n minus I minus 1. So that should build the prefix and suffix. And now we need the result. I wonder if I do none or if I do like just one. Okay, let's just start with none. So the result should be this would not work if the length of these, if the length of the input is just 1, because this would end up out of index, out of range. Okay, length is at least 2. All right, then that's fine. Okay. Last result is now for everything in between. Let's do, what do we need in between? Dot. So prefix j minus 1 times suffix j plus 1. So j starts from 1, so this one we have minus 1 plus 1, then it goes to 2, minus 1 plus 1, minus 1 plus 1, and it should stop when j is at n minus 2 actually. Yes, so this will make sure that it stops at n minus 2, because that's n minus 1, this is n minus 2. All right, do we need to return results? Let's see. All right, so that's my current solution. Let's have a look. Oh. Okay, that worked. That's good. Yes, this works. Oh my god, this feels so great. Apparently, I did this last year, about a year ago. And this got really good runtime. It's very surprising. Okay, let's do time and space analysis first before we go look at the follow-up question. So let's see, time. This is linear time, building the prefix suffix arrays or lists, that's linear time. And this is linear time, so this does have linear time. What about space? It's linear space because I'm using additional data structures that's the same size as the input. So that's linear space. Yeah, and the follow-up is constant space. Constant space. Constant space, then we cannot store the prefix and suffix lists. Constant. constant space. Well, I cannot think of a way to use constant space. Okay, failed at coming up with the constant space follow-up. Let's have a look at other people's solution without extra space. Wow. All right. So what we have here, result is the last one times the last. Okay, so if that's the example, so first we have result 1 is the last one times the, oh, wait, so this is not doing this prefix because it's using the last one times the last element in nums, not the current. Okay. That's weird. This is very mysterious. See, so this is last one times the last number, last times last number. Oh, last times last number. Okay, that makes sense. And then the right times, so current one is going backwards, and then going current one times right, and the right is also updating with current number. Okay, so the right ones we are doing times right. I see, so first that times right, and then right is updating with the last one and current. Well, this is annoying, so let's just let me just have this here. can have a look at the same time. Okay, goodness. Oh no, what have I done now? Okay. Okay. So we go from this one times right is initiated to be 1, then right is updated by current number, so right is now 5. Now we are here, this is that left part times right. Now we update right with current number again, and now we're here, we're multiplying left part with the right part. Yes. Wow, this is so smart. I do not understand how people can come up with these brilliant solutions. It's just amazing. Wow. This is an amazing solution. Indeed. Okay. Well, that's it for this one. I'll see you in the next problem. Have a great evening.